And welcome to the week 4 lesson. So the topics for today, excuse me, are going to be variables, string objects, and the scanner class. It's going to be kind of fun because we're going to talk about how you can actually prompt users to enter data and receive that data from a console and then use that data to really make your programs dynamic. All right, so our objectives are to really expand upon implicit and explicit parameters, really define out variables, instance variables, local variables, parameters, static versus final keywords, the different operators, string objects, and scanner class. So just a lot of little things that we've been talking about kind of already, but we're going to pull some things together. All right, so implicit versus explicit parameters. So an implicit parameter is implied. It's implicit, it's implied, whereas an explicit parameter is explicitly defined. So an implicit parameter means it's implied, it's always there, but you don't necessarily see it, where an explicit parameter, you can see it. It's right there. It's explicit to you. All right. So when a method is called, so implicit parameters, it's applied. When a method is called, there is always an implicit parameter, and that implicit parameter is the object that is calling the method. So we've used the format object name dot method name, and then with your open and closing parentheses, the object name in the front, that is your implicit parameter. So it's the object that's calling the method. So whenever you see a method which has got that open and closing parentheses, right, that's kind of your key that that's a method. You're going to go in front of that method and look for the period, and then right in front of the period is going to be your object that's calling that particular method. All right, explicit parameters, these are explicitly defined, and these are inside of the parentheses, all right? So when a method is called, there is always an implicit parameter, right? There's always an object that calls that particular method, but there may or may not be explicit parameters. So there can be 0 to many explicit parameters, but there always is just one implicit parameter. And if there are explicit parameters, they're going to be inside of the parentheses. All right, so let's take a look at this, tempstudent.getAddress. So right away we can see our method, right? We've got the open and closing parentheses. This triggers us that this is a method. So we're going to go looking for implicit parameters. We're going to look for the period and then go in front of that, and that's going to be the object that's calling this particular method. So the implicit parameter is tempstudent. This is the object name. As far as explicit parameters, we're going to go right away to those parentheses and look there, and there are nothing inside of the parentheses, so there's no explicit parameters in this example. All right, for this example, again, you're going to look for your parentheses. We've got those. You're going to back it up. Here's the name of your method. Look for the period. Your implicit parameter is pet1. Explicit parameter, you're going right for the parentheses. There's one explicit parameter of data type string, and in this case, it's a string literal value of Duke. It's literally the characters D-U-K-E. All right, local variables. So local variables are defined within the body of a method. So maybe you need to do some computations, so you're temporarily storing values into a variable. All right, these would be what's called a local variable. All right, it has to be initialized to a value before it can be used. And in particular, the scope, which is where a variable it can be accessed, the scope, it comes into existence at the point at which it's declared inside of the method, and it ceases to exist when the method ends. So the scope of a local variable is the method within which it is defined only. All right, it's not available outside of the method. It's not available before the method or after the method, within the method itself only. Parameter variables, these are declared within the header of a method. So when you look at the public statement where we've defined a method inside of our user-defined data type class, right? And you'll see that we are defining variables, the parameter variables. We would give it like string in name, string in age, and etc. We're actually defining those variables right there in that header statement of the method. So they're contained within the parentheses. They're passed as arguments when you call the method, and the scope is the same as a local variable. It comes into existence at the point it's declared, so within the method header, and it ceases to exist when the method ends, so it's only available within the method itself. All right, now an instance versus a parameter versus a local. So if we take a look at this, we've defined our class up here at the top, public class pet store. We have an open curly bracket and then a closing curly bracket. Well, this we would have, I'm sorry, I'm missing one closing curly bracket for the pet store class. Then we have a couple variables that are declared here. Then we have the pet store constructor here with some explicit parameters, and then the instance variables are assigned values to these. So if we look at this, what are the instance variables? So we have two instance variables that are defined at the level of the class. We have store name and store number. The scope is the entire class. So it's available from the first line of the class to the last line of the class. The parameter variables, on the other hand, are inside of the parentheses. So we have in name and in num, which are parameter variables here. The scope of the parameter variables come into existence when the method is defined, so line 4 until the method ends, which is the closing curly bracket here for this particular method, which is line 7. Or you could say line 5 and line 6, it doesn't matter to me, but it exists here for the duration of the method. And in this particular situation, there are no local variables. You would look for the data type when you're defining a variable. So, sorry about that. So here we have a data type that's defining our instance variables. Here we have data types defining our parameter variables, but there's no other variables that are defined like within this constructor here. So there are no local variables in this particular example. All right, so let's take a look at this one. We have a class again. We're defining two instance variables up here at the top. We have just a regular method, returns data type string called display store info. We do declare a variable here. We have a data type string output equals, and then we return what is contained in our output. So our instance variables are store name and store number. We have no parameter variables in this circumstance because if we look at these parentheses, the parentheses are empty, so there's no parameters. But we do have one local variable called output. It comes into existence here on line 5 when it's defined, and then ceases to exist on line 7 when this display store info method ends. So its duration is this method only. Up here, we don't know about output, and down here, we don't know about output. And I guess coming back here as well, up here, they don't know about in name or in num, and down here, they won't know about that either. The scope of these two parameter variables is this constructor only. All right, constants. So constants are values that don't change. They're constant, right? And you use a constant to avoid a phenomena called magic number, where you just suddenly have a value appear inside of your code. Like, let's say, for instance, let's take the quarter example we have down here at the bottom, that scattered throughout your code, you have a 0.25 value that maybe you're multiplying by something or adding to something, and your question would be, what is 0.25? Like, what does that represent, right? And so better is to declare a constant up at the top as an instance variable essentially to your code, so it's a constant, a value that does not change, and give it a variable name such as quarter, like we've defined down here at the bottom. Then throughout your program, rather than multiplying things by 0.25 or adding 0.25, you would reference the value quarter, and it would make a lot more sense to you. You would be like, oh, okay, I'm multiplying this by the value of a quarter, or I'm adding to it the value of a quarter. Likewise, if the value were to change for some reason, so let's say a quarter instead of being worth 25 cents is now suddenly worth 30 cents, you only have to change it in one place up at the top where you defined your constant. And then everything throughout, because they're referencing the variable constant name, is automatically picks up this new value. Now, I know it doesn't make a lot of sense if we're using a quarter in this example, but let's say it's a discount rate instead, and so our discount rate initially is 0.075 and we want to make it 0.06. then that makes more sense. You know what I mean? That you're just changing your constant value and it propagates throughout the entire program. Now, to create a constant, it's declared with the keyword final, and it can never be changed what's set. So you set it one time and Java will not let you change it again. Now, a Java convention for a constant is that it contains all capital letters. So here we made it public. It doesn't really matter to us whether a constant is public or private, right? So we're not worried about encapsulation. It's a constant value. Final, which says this is the final value. It's not going to change. This is what indicates it's a constant. Then the data type of double. And then the Java convention is the name of our constant would be all in capital letters, assigning it 0.25, and we cannot now change this value. It is 0.25 for the entire duration of the program. All right, static. So a static does not define a variable as constant, all right? The final keyword is what sets something as constant. But what the static keyword does do is it says it belongs to a class, not to the object. Okay, so what we've done is, so let's say, for instance, and for most constants this would be relevant, you have a value and it's not going to change for any of your objects. It's always going to be the same for every single object. So why, what do I want to say? So each object does not have to have its own copy of that constant, right? Why not just have it exist one place in memory and let all of the objects just look to that one constant value? And so that's what the static keyword does, is it says you don't need to create a new version of this for every single object. Instead, I'm just going to create one version of this, assign it to the class, but all objects are going to have access to this particular value. Okay, so here's how you would define that. So public, anybody can access it. We're not worried about encapsulation. Static, which says it belongs to the class. It doesn't belong to the object, so there's only going to be one instance of this variable, not an instance for each object. Final, which says it's a constant value. It's not going to change. And then interest rate, which is our Java convention of signing this all in capital letters, and equals 0.01. Now, it doesn't necessarily have to be a constant value to be static. There could be other things that you might use a static variable for. And in your book, it gives a great example of an account. So we might use student ID, for instance. So let's say we store in our class, we have a static variable. It's not a constant. That's called last student ID. And it's set to whatever was the last student ID that we used. And so now we're creating a new student, so this belongs to the student class. We create a new student, and because the object has access to this particular variable, they go and they get the last student ID, and they add 1 to it and assign that now to the student that's just been created, and they bump up the one that's in the class. So you're keeping kind of a running total to tell you what's the next, how do I generate the next student ID? Or we could use it for a bank account number, or you could use it for a credit card number, and so on. So that's where a static comes into play. It belongs to the class. It does not belong to the object. There's only one instance of a static. It may or may not be constant. All depends upon the program and the design of the program, and it's indicated by the static keyword. And all objects created from that class will have access to that static variable. All right, so here we have public string default name equals unknown. So we're asking, can this value be changed? So can this value be changed here? And the answer is yes. Although it looks like a constant because we've used all capital letters here, it does not have the final keyword, so this value could indeed be changed. This is not a constant. It's a poor use of the Java naming conventions. All right. Does this belong to a class or to each object? It belongs to each object. It does not have the static keyword. Here, public final integer min value equals 1000. So this value cannot be changed. It's got the final keyword, which tells you it's a constant. This is its final value. And it also belongs to each object. It does not have the static keyword, so each object will have its own version of this min value variable. Public static final double coef equals 14.78. This is a final, so it is a constant. It cannot be changed. And it belongs to the class. It has the static keyword, so it belongs to the class. So there's only going to be one instance of these variables. No, the objects are not going to have their own version of it, but they can definitely go to the class and access the one instance of it to get the value of this coef constant. All right. So that kind of was a quick review of implicit versus explicit parameters, local, the scope of instance variables, parameters versus local variables, and then talking to you about constants defined as final, and then also variables that can be defined as static, which indicate that they belong to the class as opposed to each individual object. So we're going to talk a little bit about calculations here, and calculations follow the same rules as what you encountered in algebra. All right, the same order of precedence applies. So however you want to remember that order of precedence, where you're doing the PEMDAS or the My Dear Aunt Sally, but the order of precedence is going to be parentheses first, then exponents, multiplication, division, modulus, addition, and subtraction. Okay, and this is really key here. All right, so the operators that we're going to use when we're doing our calculations with the computers is an asterisk will be multiplication, and X could be an actual valid variable name, so we wouldn't want to use X here. We're going to use the asterisk for multiplication. Your slash is your division, a percent symbol is a modulus, and I'm going to go over that for you. Addition and subtraction are your common symbols that you would anticipate. All right, so division versus modulus. Division will return our result. So if we had double result equals 5.0 divided by 2.0, the result variable is now going to contain the value 2.5. The modulus, on the other hand, returns the remainder. So if we had double remainder equals 5.0% 2.0, the remainder variable is going to contain the value 1.0. 2 can go into 5.0 2 times with a remainder of 1, so the modulus contains the remainder. All right, I'm going to tell you that in my programming career, I have not had a great opportunity to use the modulus a lot, but it does come up every once in a while. Okay, I have used it when I've wanted to display like a different image on a different day, you know, so I will take the current day of the week and divide that by 7, and whatever that comes up with, then it tells me which image I need to display, or I might use it to display a different image based upon time. I've used it to calculate, I don't know, just a variety of things, but I don't use it a whole bunch, but it does serve its purpose. All right, in addition, for integer division, so it's not enough that you have regular division and you have a modulus, but we also have something that comes into play called integer division. And in Java, integer division is when you divide one integer by another integer, and the result will always be an integer. So here we have integer result equals 5 divided by 2. The result is going to be 2 because 5 is a whole number, 2 is a whole number, so the result is 2. So even if I change this to be double result equals 5 divided by 2, it's still only going to attain the value 2 because I've got integer division. These are 2 whole numbers. Now to get decimal division, you need to change one or the other to a double value. Okay, so double result equals 5 divided by 2. This is still going to give me 2. These are both whole numbers, so the result is going to be a whole number and it ignores the integer. Or I'm sorry, it ignores the decimal. Double result equals 5.0 divided by 2. 5.0 is a double value, so this is going to give me 2.5. And 5 divided by 2.0 because 2.0 is also a double value, this is going to give me a 2.5 as well. So this is something you really, really, really need to pay attention to. It's super easy to ignore the fact that you're dividing two integers and that you're only going to get an integer result. So you want to be very, very careful when you're doing your division that you're getting the result that you're anticipating. So if you're anticipating double division, make sure that you're either the one or the other is data type double, or that you're casting, which we'll talk about a little bit later. You know that you are definitely doing double division if you want your result to be a double value. All right, so integer division with variables. So here we have num1 and we have num2, so they're both defined data type integer, and we have 5 and 2 here. So these are both integer values. So if I have double result as num1 divided by num2, that is indeed integer division because these are both integer values. The variables are defined as integers. Now, if I wanted to switch one of them to be a double value, I can just multiply it by 1.0. Num1 times 1.0 divided by num2. Notice my parentheses to force this multiplication before the division. Now I've converted num1 to be a double value, and my result will be double. Or I could change my denominator, so I could have num1 divided by num2 times 1.0. Again, notice the decimal places, or I'm sorry, notice the parentheses here to force the multiplication to occur before the division, and the result's going to be 2.5. Now, if we were following our order of precedence here, because the multiplication would occur, you always go left to right. So the multiplication would occur before the division, so we don't necessarily need the parentheses. But in the second example, num1 would, since it goes left to right, it would first, sorry about that, it would first divide num1 by num2, and then after the division over is multiplied by 1.0, so you'd end up with 2.0, not 2.5. So this is where those parentheses really come into play, where you want to force this multiplication to occur before the division. And I would actually argue, even though it won't change the outcome here, you never get penalized for too many parentheses as long as they're all evenly paired, but you could definitely cause an incorrect result if you omit some parentheses. So I would always err on the side of caution and incorporate parentheses as opposed to leaving them out. Okay, the math class. Now, the math class is a library class that's provided for us, and this allows for different mathematical computations. So this is what's considered a static class. No objects are created from this class. Okay, and it just provides us with a ton of different computations. So the Java developer said, let's not make them determine the calculation for raising something to the power or absolute numbers. I mean, we could certainly write programs to write code to generate those values, square root, and so on. But these are very common things. So the Java developers have provided us with the math class to do that for us. So when you're calling these methods are static methods. Since this is a static class, all the methods within the static class are also static. They belong to the class itself. We're not going to create an object. There's no objects created from the static class, but all of the methods are available to you to be used. And so it's going to be math.pow, and then you provide it with your parameters, the parameters that are required. So this is raising num1 to the power of num2. Here we have math.abs with the absolute value, so it provides one parameter and it will return the absolute value of that number. You can go out to the Java docs and look up the math class to see all of the different static methods that are available for you, what parameters are required, and so on, and what values that they return. I should come back here. So earlier I was telling you look for the method and dot, and then this will be an object. You're going to know this is not an object here because you have a capital letter, so this is a class. Remember, the Java naming conventions are that classes start with a capital letter. So you can tell when you look at this, you can find your method, look for the parentheses, this is my method, look for the period in front of my method. Here we go, starts with a capital letter, this must be a class. Okay? All right, data types. So up till now, we've been working predominantly with primitive data types and then our own user-defined data types, right? So primitive data types, there's no methods, just data. So we've been using integer, int, integer for whole numbers. We've been using double for decimal numbers. There's also Boolean, which contains a value of either true or false. And there's char, which is a single character. Now that char, as far as being a single character, it's enclosed in single quotes, where your string data is enclosed in double quotes. A char is enclosed in single quotes. And we're going to see a single character. So for example, we're going to see a capital A or a lowercase c or something like that. There's going to be one character inside those single quotes. But what the computer sees is the ASCII equivalent. So the ASCII encoding scheme for that particular character. And I don't know those numbers off on the top of my head, so this is just a for instance. You can definitely go out to Google and look up ASCII encoding scheme and you'll get a whole table that'll show you all the different codes. But for instance, a capital A might be the value 65. And I don't know that, okay, so don't hold me to that, but it's going to be some number. A space is also a character that can be represented with a single quotes. A char is the number 20. So I do know that one, but I don't know all the other ones, okay? But that's what the computer sees. So we'll see a space, the computer will see the value 20. We'll see a capital A, the computer might see a value 65 or something along those lines, right? Primitive data types all start with a lowercase letter. All right, so notice integer, double, Boolean, and character. They're all starting with a lowercase number. It's data only, no methods associated with the data. Okay, complex data types. These are classes, and so we've been creating those with our lab 1, and we'll create those with all of our labs throughout the class and with your homework assignments as well. They are complex data types. These are classes, and they contain both data and methods. And we've actually been using one of these complex data types all along. We just tend to think of it as being primitive data, but it's really not. And that's your string class. Okay, it starts with an uppercase letter, so when you're defining your data, string always starts with an uppercase letter, and it contains both data and methods, so there's actions that can happen upon that string data. Okay, so string, and I gave this away, string, is it primitive or complex? It is complex because it starts with a capital S, so this is a class, so it contains both data and methods or actions. All right. So the instance variable is text-based data. It can contain both alphabetic, numeric, and characters. All right. All of the methods are accessor only, meaning the original value is never changed. The original value stays the same. It may manipulate it and return a different value, but the original value itself will remain unchanged. And that gets me all the time. So I'm sure that's something that will impact you too, where I might call like a replace function to say replace all of this character with that character. Well, the original string is not going to be changed. It's going to stay the same. It's just going to return to me a brand new string with the replaced action having taken place. And the same with uppercase or lowercase or all of that stuff. It's just returning to you a new, like a copy of the string with that action upon it. So the original string will always stay the same. You can go out to the Java docs here and you can take a look at the string class and all the different methods that are available to it and what those methods return, what they expect as far as explicit parameters, and what they do. So you can take a look at that and see. And remember encapsulation. Okay, We don't know how the string class is written, but that doesn't mean we can't use it, right? We can still create string objects. You've actually been doing that all along, and we can call the methods on the string object to return to us new copies of that string with that action taken. So encapsulation or a black box, we don't know what's going on in there, but we can still use it. All right. So the string class with accessor methods, and again, I cannot stress enough, it does not change the value of the object. With string data, the data always starts, or the first character is always in position 0. So let's say we had a string that contained the characters for hello, H-E-L-L-O. H is going to be in position 0, E in 1, 2 in L, 3 in L, 4 in 0. Or, sorry, O in 4. Okay? So it's always going to start in position 0. So it does contain 5 characters. It's going to be in position 0 through 4. So it's really important. Java does this throughout the whole class. Everything's going to start in 0. All right. We have some string methods, some common string methods. So we have the length method, which returns to us the number of characters in the string. So in the case of our hello, this would return to us an integer value of 5. We have the to lowercase, which is going to return to us a copy of the string, all in lowercase letters. Remember, it's not going to change the original string. The original string will still contain lowercase characters or whatever, but it returns to us a copy of that string, all in lowercase. And then we have the to uppercase, which is going to return to us a copy of the string, all in uppercase letters. All right. So the format for calling a string method, remember this is an accessor method, so it's always going to return something. So you need to have a variable here set equal to your call. So whatever is being returned in the case of a length, it's going to return an integer value. So you have an integer value here, whatever you want to call your variable equals the string.length. Or in the case of a to uppercase or lowercase, it's going to return a copy of the string. So it's going to be string equals whatever your string is, dot to uppercase or to lowercase. It will always return something, so you want to assign it to a variable, otherwise you're going to lose that value. All right, so here we'd have dot length returns the number of characters, and it returns it as an integer value. So I'm defining a string with a variable name of name equals Fred, and then I'm calling name.length, open and closing parentheses, no explicit parameters are required for the length method, and I'm assigning that, so I have my variable here, a local variable, integer name len equals name.length. So the value of 4, there's 4 characters in my string Fred. This variable here is now going to contain a value of 4, so when I print this out, it's going to display 4 on the console. Okay, to lowercase returns a copy of the string, all in lowercase letters. So again, if I go with Fred, here's my string. It's going to return to me a copy of the string, so I need to put it into a string variable here, and I called it name lower equals name dot to lowercase. And this particular method does not require anything in the parentheses. And if I were to print this out, I'm going to get Fred all in lowercase, so F-R-E-D, all lowercase letters. The original string, however, is going to be this. So name is not changed. Name lower contains Fred all in lowercase. Name still contains Fred with a capital F. And likewise with the to uppercase, it returns a copy of the string all in uppercase characters. So string name equals Fred. String upper equals name.to uppercase, empty parentheses, no explicit parameters required. And when this gets called, it's going to return into name upper Fred all in uppercase letters. So this is what we're going to see here, F-R-E-D all in uppercase letters. Okay, so if we were to take a look at this, string class name equals COMP-111. If we were to call the name.length, so class name.length here, what value is class length going to contain? And so if we count up here, 1, 2, 3, 4, 5, 6, 7, 8, it should contain a value of 8 because there's 8 characters in that string. All right, looking at that same, if we call the two lowercase and put it into class lower, what value is class lower going to contain? And it's going to contain COMP-111, but all of these comps here will all be in lowercase characters. Now, class name itself is going to continue to contain this original value with the capital C because it's an accessor only. It does not change the original string. It just returns to you a copy with it manipulated. And likewise with the uppercase, same string value, class upper would now contain capital C, capital O, capital M, capital P, hyphen 111, where class name is still going to contain this original value. All right, the substring method. So the substring method is going to return to you a portion of a string. All right, and the format for calling this method is object name dot substring with two values here. So your integer value here is the starting position, and this is your ending position. Now, it's a little bit different. The starting position is the actual physical starting position of the character in the string. So it says start right here and include this character, so it's inclusive. But the ending position is exclusive. It says go up to, but do not include this ending position. So it's a little bit confusing there because you don't include that ending position. All right, so here's your example. We're back with our COMP-111 here. All right, so we have our phrase defined, and we said we want to substring, so we have phrase.substring 0, 3. So start at position 0, go up to, but do not include 3. So 3 is exclusive, 0 is inclusive. So COM, go up to, but not include P, so we start right here. So the result is our sub variable will now contain COM. Okay, it's not going to contain COMP, it's only going to contain COM. All right, here we do it again. We say 0 to 7. So again, 0, we're going to go up to, but not include number 7. So we're going to stop right here with position 6, and we're going to end up with COMP-11, not -111. Okay. Now you can omit the second character, and it is only going to, what it says is I want you to start with this position and go all the way to the end of the string. So if you know you need to go all the way to the end of a string, just omit the second variable. You don't want to risk specifying an incorrect variable and maybe lopping off the last character or last couple characters. So if you know you need to go all the way to the end, just omit that last character. Now this one says start in position 1, so we're starting right here in position 1 and going all the way to the end. So our result is OMP-111. Okay. Now you can combine methods together. So we can use the substring in conjunction with the length as well. So again, we still have our phrase, and then we say, I want you to start with position 1. So start with here, go up to, but do not include, and this would be the length of -1. So there are 8 characters inside of this particular string, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here generated by this. So this generates a value of 8. -1 makes this 7. Go up to, but do not include 7. So we're going to end up with OMP-11. Okay, and this is what we're going to end up with. So if you need to manipulate things and you need it to be like a specific value, based upon the length, like maybe you know that the last 3 characters of a string are always something and you don't want to include those, but you don't know how long the string is going to be, you just know you don't want to include the last 3, you can use something like this where you generate the length and then subtract 3 from it, and it would remove those last 3 items for you. Okay. So that is the string class. There are a lot of different methods out there, and so there's index of, which tells you where a phrase might be found in a string. There's replace. There's just a ton of different string methods out there, and so I really encourage you to go out to the Java docs and just kind of take a look and peruse around to see what's available to you. Okay, concatenation. So this is also something that's used with string, but it uses string, string with string, and then string with other data types as well. So what concatenation is it's combining variables together. So it's not adding or multiplying or dividing or anything like that. It's combining. So when you combine a string variable with any other data type, it's going to convert that to be string data. But it does combine exactly as written. Okay, the computer is not going to say, hey, I bet they want spaces in here, or I bet they want, quotation marks, or they want something else in here. The computer is going to do exactly what you tell it to do, no more and no less. All right. So here we have string new string equals var1 plus var2. Okay, this is concatenating the contents of these two variables together. Now, if these two variables are indeed both numbers, it will add them. But if one or the other is a string, it's going to concatenate them. So let's say, for instance, we have F name is Fred and L name is Jones, and we want the full name to be F name plus L name. Remember, it's going to combine it exactly as written, so when we concatenate these two string values together, we end up with Fred Jones with no space in between. Probably because we have a first name and a last name, we're going to want a space in the middle. But unless you specifically tell the computer to put a space in there, the computer is not going to do it. So it only does what you tell it to do, no more and no less. All right, so if we look at this, we have var1 plus var2, and in this time we have F name equals Fred, num equals 17. So we're going to concatenate these two together. And remember, as soon as it hits a string, it's just going to convert everything else to be string data. So we have F name plus num. We're going to end up with Fred17. Okay, so Fred17 is what we end up with here. No spaces or anything else. To indicate why we have Fred17, it gives us exactly what we told the computer to do. All right, num1 is 17, num2 is 27. We're generating an output into the variable new string. The result of num1 plus, and then we have a plus symbol inside of quotation, so it's a string literal value of plus num2 is, and then we have num1 plus num2. So what we're probably wanting to do is get the result of 17 plus 27 is 44, right? But what we end up with is the result of 17 plus 27 is 1727. Remember, when you are concatenating together like this, as soon as you hit a string value, it automatically converts everything else to string. So the 17 becomes a string and the 27 becomes a string here, and it just concatenates or appends them together. It will not add them together. However, you can force the addition, and that's what we have down here. The result of num1 plus, and then our plus sign is a literal value here, plus num2 is, and we put it in parentheses. Remember, our order of precedence PEMDAS, parentheses always occur first, so the addition will occur first inside of the parentheses, and then all the concatenation will appear, and it will give us the result of 17 plus 27 is 44. All right, so here's just some different concatenation problems or examples. So we have string 1 is learn, string 2 is Java, string 3 is programming. We have a space defined as a space, and then we say the sentence equals string 1 plus space plus string 2 plus string 3. And what will this output contain? It's going to contain learn, space, and then Java programming all smushed together. Okay, we did not put a space here, so it's going to smush things together. If you want a space, you have to stick it everywhere that you want a space to be. And so this is what it's going to look like, learn, space, and then Java programming. All right, double temp1 equals 10 and temp2 equals 5.0. So our output is temp1 plus, and then we have an asterisk inside a quote, so this is a string character, plus temp2 plus, and an equal sign in quotes, plus temp1 times temp2. Now remember, order of precedence, multiplication is going to occur first. So we're going to do 10 times 5 is 50, and then we're going to do the concatenation. So we'll end up with 10 asterisk 5 equals 50. And we didn't put any spaces in there, so it's going to be all smushed together like this. All right. Now you can take concatenation and you can actually combine methods along with your concatenation to give you better results, all right? So we have this string called temp, which is Java programming is great. And then we know we can do the length to generate us how many characters are in that particular string. So we can say temp plus contains, and then we can call the method temp.length characters, and we would end up with Java programming is great contains 26 characters. So you can combine methods along with strings to generate you output. All right. Here we have new string equals methods and strings, and we have our output equals uppercase plus, and then we do new string dot to uppercase plus the lowercase plus new string dot to lowercase. And so here we have uppercase method and strings, lowercase method and strings all in lowercase. So just a different example of how you can combine methods along with concatenation to generate output. All right, almost to the end here, but to the fun part. So the scanner class. The scanner class allows us to accept input from the console. Now, the scanner class is not a default class. Like, for instance, the math class, we don't need to worry about importing. It's automatically there, but the scanner class is not automatically there. You have to actually import it in order to use it, and so you import it with the statement import java.util.scanner, and this goes up at the very top of your program, the very first thing in your program to indicate that you're importing this particular scanner class. Inside of your program, you have to create a scanner object, and that is done with scanner, and then you can call it anything you want to. I chose to call it input equals new scanner, and then you provided a special system.in parameter, and this tells it to accept input from the Windows console. Okay. We have a bunch of methods available to us to accept input off of that console, so the next method will return up to the white space, up to the first space that's entered. The next line returns up to the carriage return line feed, which is your enter key. The next integer returns an integer value, and the next double returns a double value. So on that dot next versus next dot next line, what you have to ask yourself when you're trying to decide which one you want to use is there a possibility that the value that's entered could contain a space? Like, for instance, if I was entering in my name, there's a likelihood that my name could contain a space. So because there is that likelihood, I'm going to use next line to take in the value, not next. Otherwise, if I were to enter my name, Tina space Compston, and I use next, it would return Tina only. And then the next time I called it, we return Compston only. It's not going to give me my full name that I entered. So if there's a possibility that something could contain a space, you use next line. If there's no possibility it can contain a space, you can use next. All right, so here's how this might look. Up at the top of your program, you'll do an import statement, import java.util.scanner. Then inside your program, you're going to create a scanner object, and I chose to give it a name of input. Then I'm going to prompt the user, enter your name, and then I'm going to do an input.nextLine. So input is my scanner object. I'm calling the nextLine method on my scanner object, so it retrieves everything up through the enter key and puts that value into the name variable here. Now this is really super important right here. System.out.println, enter your name. Okay, you need to tell the user that you're expecting them to enter some information. So you need to prompt the user and tell them, hey, I need you to enter information and this is what I want you to enter. Right? Nothing is more frustrating than when you're using a website and they don't tell you what it is that you need to enter, right? So you need to tell the user that you need them to enter something and then tell them what it is that you want them to enter. And if there's a specific format, like for a name or a credit card or a date or something, give them that information as well. All right. Here's another example. We've imported our scanner class. We've created our scanner object. We said enter your age, and this time I did a next integer. So I'm prompting for entry of the age here with a next integer value. All right, so that brings us to the end of the week 4 lesson. Certainly, if you run into any questions, please do not hesitate to send me an email or to post something out to Piazza.